The features and functions of any Midtronics analyzer make it ideal for stationary battery management where reliable backup power is absolutely critical. The analyzer is a microprocessor-based tool designed to perform conductance tests of any 2-volt through 16-volt battery, either online or offline. Before conducting any tests, it's important to take safety precautions required by the facility or your organization. Be sure to protect your eyes. Remove all jewelry, including wristwatches. Also, never forget that analyzers are not designed to test entire strings at once. Test individual batteries or jars only. We begin with a visual inspection. Look for evidence of battery problems, like post-seal leaks, positive plate growth, fractures or ruptures around the post areas, and cracked or bulging cases. Also smell for hydrogen leakage, a rotten egg smell. All of these are indications of serious battery problems, and while you're at it, make sure the hardware is torqued properly. As part of your setup, be sure to test for temperature, which will affect conductance measurements. Scan the entire battery system, starting with jar 1 and working to the end, concentrating on the posts and connections. When you finish temperature testing, check the reading on your sensor. You will need to enter the average manually during the setup. The purpose of a conductance test is to diagnose whether or not the battery has a discharge performance problem. As a battery's performance declines, so does the battery's conductance. It's important to remember that voltage is only an indication of a battery's state of charge and not its performance capacity. Let's define a few terms. The basic value of conductance is expressed as Siemens or Mohs. We're looking for similarities in the battery measurements compared amongst themselves or against an established baseline measurement. The further away from that reference measurement, the more likely it is that the battery has a discharge performance problem. If so, the situation may require further investigation. The Celtron Ultra test kit from Midtronics includes a state-of-the-art microprocessor tester. It's the only analyzer in the entire industry that's capable of developing reference data under your direction. It's a highly graphic icon-based system, which makes navigation much easier and quicker. It also incorporates a secure digital memory card, which can store data for up to 500 strings, with 480 test results in each string. It interfaces with the PC for storage and data management, and it's updatable as software changes become available. The kit's interfaces and accessories have been improved with new lighted DuraProbes that are useful for locating secure contact points on leads in dark areas. The tips are pointed to help penetrate through deposits for a better contact. To protect its circuitry, the Ultra will not turn on and display or sound a warning if the clamps or probes are connected in reverse, red to negative, black to positive. A small box in the upper left corner of the display shows the charge level of the analyzer's internal battery pack. Another versatile feature of the Celtron Ultra is the built-in digital multimeter. Under DMM, you can measure both DC and AC voltage and current. The scope mode displays AC ripple current and more. The kit also includes a digital infrared temperature sensor to measure jar temperature, DuraClamp cables, an infrared receiver, an infrared-driven printer, a memory card reader, and a spare rechargeable battery, all contained in a protective carrying case. The infrared eye is located on the top of the unit and is used to communicate with the printer and a PC. This is the interface where you attach probes and clamps used during the testing. A recharger is included with the kit along with the spare rechargeable battery. The battery is located on the back of the unit. One feature of the Celtron Ultra that gets your immediate attention is the new alphanumeric keyboard. It operates in a manner similar to a cell phone directory, where characters can be created from the number keys. Which brings us to the subject of setup. To begin, make sure the memory card is loaded. As you go through the test routine, be mindful of all required procedures as prescribed by the organization for whom you are conducting the tests. Let's start with the DuraProbes. To begin testing, press and hold the power button. Select Battery Setup in the main menu section and press the Enter key. In this case, we will be conducting a new test, so select New and press the Enter key. We should identify the string or location we will be testing, so we should overwrite the string name by pressing Enter. Then press the back key to delete letters. Because this unit features an alphanumeric keypad, we can spell out the new name for this string. When we have finished, press Enter. We can change test settings easily. In the string info list, use the arrow keys to scroll through your options and press Enter to select. It's extremely important to enter the correct number of jars you're testing in this string. Before you enter a number in jars per string, count them. Generally, jar or battery testing is done against a set of reference values. The Celtron Ultra gives you more options than any analyzer yet invented. For testing with reference values, you have three options. One is to use a reference from the Celtron Ultra database. Select Battery Manager. Select Manufacturer. Scroll to a manufacturer's name and press Enter. Select a model. The idea is to match reference values to the actual models you're testing. But suppose the models you're testing do not match any in the Celtron Ultra database. You can have the analyzer create a reference standard based on the values of the batteries you're actually testing. This value is based on a percentage of batteries that have the highest conductance value. Here's how to set it up. Select Battery Manager. Select Reference Developer. This will allow you to use the top or highest value. Press Enter to accept 30%, which is the default setting. Or you can set your own parameters, say 20%. Just use the arrow keys or keypad to make your selection. Your third option is to develop your own reference value. Select Reference. Use the arrow keys or keypad to select a percentage, then press Enter. Finally, if you wish, you may test without a reference value. Select Reference. Use the arrow keys or keypad to select 0. Then press Enter. Now you have selected the parameters of your choosing. So select Save and Test and begin testing. Or you can select Save and Continue, and you're ready to create or update a new file or string. Your parameters are set, and we have selected Auto Start. For convenience, you can clip the tester to your belt. There really is no need to look at the display while you test, because the unit gives you an audio indication each time the test is complete. Let's start with the DuraProbes. It's important to understand where the best contact points are. One contact point to avoid is the stainless steel hardware. Stainless steel gives lower test readings, possibly even a false failure indication. Instead, make sure the probe touches directly onto the lead post. This registers the highest measurement and the most uniform information. One thing to keep in mind is to be consistent. Utilize the same contact points each time. In 4 or 6 post batteries, the common practice is to take one measurement. But if you do it this way, be consistent. Select the same 2 posts each time on each jar. You can also set up the tester for 4, 6, or 8 posts and test each part individually. Now that the testing is completed, we can begin to interpret the data. We can view it 2 ways. We can select String and Jar Summary and view the average percentage of the conductance value, average Mohs or Siemens, total jars, and low and high jars. Using the printer included in the kit, we can print the summary and jar data in a tabular format. Here's how that's done. Line up the infrared eye of the unit with the infrared printer. From the Set Parameters menu, you can select Print Results. In a few seconds, the results are printed in the order tested. We can also select a file or string, such as the one we just created, to view data for individual jars. This enables us to look for jars with the lowest readings. This report can also be printed. Let's examine the lowest reading, jar number 2. It falls below the reference value we set for this test, so we should verify this by retesting. If you want to retest, return to the menu and go to Reports Jar Data. Select the string you were testing, then scroll through the test results until you find the jar in question. Then press Retest again. In the retest, make sure you use the same contact points as in the original testing. The results of this test will replace the reading you had before for this jar. We now see that the low reading has been confirmed. We've just performed our first test. We suggest that you follow it up with a test of the conductance of the straps. Rich is attaching the clamps and has selected jars and straps in the Set Parameters menu. Now he's going through the test routine, testing first the jar. On completion, we move one clamp to include both jar and strap, in this case jar 1 and the inner cell connection, or to jar 2. This measures the slight increase in resistance or loss in conductance through that strap. We continue on with jar 2. Test that jar, then again, including the strap. After we have tested both jars and straps, we can review that information. For example, strap 1 reads 525 microohms. We expect to see a slightly higher measurement of the jar compared to the strap measurement. We expect the conductance measured to drop when we measure the strap. You can scroll through all your collected information to locate a pattern. The resistance or voltage drop in each of these battery measurements and strap measurements should be fairly even. Anything unusual indicates a potential problem with the strap. That completes basic testing information for string 1 at this particular site. It's important to document everything you test and leave a copy of it on site. And be sure to include information on which type of interface you have used, probes or clamps. Another way to archive test results is to utilize a PC for data storage. You can transfer reports, like the string test we conducted earlier, directly to a PC. Using the Inform software included in your kit, you can manage the data and generate reports in formats useful to you and your business. For further information on testing with the Celtron analyzer, refer to your instruction manual and the quick reference guide. Determining whether a jar is good or needs to be replaced is not simple. Consult with the manufacturers where matters of warranties are concerned. Discuss your readings and observations with them before deciding a course of action. In general, we recommend following IEEE guidelines. Also consult guidelines set by the organization or company you're testing the battery for. As for the value of conductance testing, there is an understanding that a linear but not direct correlation exists. Also, as you test and compare the results with the history of the installation, look for trending. What is changing and how quickly are the changes happening? Ideally, battery strings should be examined regularly. Every 3 to 6 months is recommended. Recently installed cells should be examined as well. And we can't stress this enough. Make sure you're not comparing apples to oranges. Whatever parameters were set in the beginning, continue to follow them in each subsequent visit. The Celtron Ultra gives you a wide range of utilities and testing capabilities. Time doesn't permit us to go into each one in detail, but you can find information on their benefits and uses in the manual. And that's why the Celtron Ultra is called, well, Ultra, the last word in battery management tools. We have just seen one of the dozens of tools developed here in the Midtronics Research and Development facilities. So many products, so much technology, so much effort, yet truly one focus: to carry battery management to new levels of accuracy, reliability, safety, and efficiency. Finding solutions for the power, communications, and data transmission industries is our mission at Midtronics.